Hello everybody, welcome to this vBrownBag session on placement of IoT workload operations within cloud environment. My name is Kenneth Moore. I'm a data scientist and PhD student working at Delhi EMC in the Open Hyperconverged Infrastructure Solutions division. My research is mainly focused on workload modeling and simulation of converged infrastructure solutions for large-scale IoT deployments. It's a collaborative project that I'm running between Delhi EMC, Cork Institute of Technology, funded under the Irish Research Council. So what am I trying to solve here? What I'm trying to solve is I'm looking at large-scale IoT workloads, and I'm seeing that they're unknown and they're unpredictable. And that's because traditional workloads, VDI and database, are predictable. We understand how they operate. But IoT workloads are created by device manufacturers, and the types of data going through are unknown to us. They're rapidly increasing. So Gartner predicts that by 2020 there'll be 20 billion IoT devices on the market. This is generating traffic, it's generating data that we haven't seen before, and therefore it's becoming disruptive to the cloud providers. So for that reason, I'm looking at the considerations that we need for supporting the architecture and the managing of software-defined data converged infrastructure environments which are hosting the large-scale IoT workloads. So to understand that, we have to understand what an IoT device is. It typically is a sensor of some sort that gathers data. That data is processed and interpreted by a processor, and then the actuator provides some action in response to that data. That in itself is not an IoT device. You have to add the networking element to it, where it can connect to a remote cloud service and add extra intelligence to the device. That's your IoT device. So IoT workloads, there's three types I'm going to talk about today. There's informational, there's interactive, and there's intelligent. Our informational type workload, we look at our typical fitness tracker. We all have fitness trackers these days. We didn't have them 5 years ago or 10 years ago, but we do today, right? A typical fitness tracker has 4 sensors: a pedometer, a GPS, a heart rate monitor, and an altimeter. That's gathering data on a constant basis, which is storing on the device until such a time as that device connects to a remote app. Once it connects to a remote app, that app in turn syncs with a cloud storage provider for transmitting that data, and in turn that app can also read the information from the cloud storage to see the historical data. So this type of workload is pretty simple. It's numerical data coming from the tracker, it's database files going between the app and the cloud service provider. But we have to consider in this scenario, packet lengths, we have to consider the frequency at which it happens. For some users, that's happening every 30 minutes. For other users, that might only be once a week, right? And then on the storage side, we have to consider typical storage things like storage capacity and IOPS and things like that. Our interactive workloads, on the other hand, adds a different element to it, right? So with interactive workload, such as an interactive doorbell, we have 3 sensors. We have a proximity sensor, we have some video camera, and we have a microphone. We have 2 actuators. We have a speaker and we have a lock, right? So in this environment, the proximity sensor sends alert through the cloud service provider to a remote app. That user can then also see the video that's happening within that doorbell, and they can hear what's happening in the proximity of the doorbell. So then a conversation can pursue there between the person at the door and the person on the app. If at the end of it, maybe the person at the door is a family member who forgot their keys, so the person on the app can hit unlock, which sends a message back to the doorbell and unlocks the door and lets the person in. So this workload in the cloud environment is very different to the previous one, because we're now handling video, we're now handling audio. The session might last 30 seconds, but we have to sustain that video and audio for that 30 seconds in all directions between the doorbell, the cloud service, and the remote app. So in this case, we've added in some additional server requirements into the cloud service. Another aspect that we have to consider here as well in the storage is our data lifespan. So while the interaction might last for 30 seconds, we may want to keep it for a period of time for reviewing previous security issues. Do we keep that for a week? Do we keep it for a month? Do we keep it for a year? We don't know. And these are things that we have to consider when we're designing the cloud service for our interactive workloads. Intelligent workloads provide another dynamic. Initially, this workload looks and feels like an interactive workload, and it is. In this case, it's an intelligent thermostat. Between the thermostat, data is going to the cloud service provider and the app, and the user of the app can either turn up the temperature, turn off the temperature, turn it down. But we can add a new dynamic to this. We can add intelligence to this service. When we add this intelligence to service, now we can do additional stuff with that thermostat. So for example, what if we want the temperature of the room to be at a given temperature at a given time? Well, in order to do that, we have to create a profile of how long it takes to heat up the room or cool down the room. All that information is going to travel through to the cloud service and become information for training at the cloud service provider. We may also need to take into consideration some external factors. Maybe we'll put a temperature sensor outside the house, or maybe we'll connect to a remote weather service which will tell us what the temperature is outside the house. Now we can take into consideration what's the current temperature of the house, what's the current temperature outside the house, what's the temperature profile for heating or cooling, and make some intelligent decisions such that we can turn on the heating at the right time such that the property will be heated for the right, at the right time. So now, in this scenario, the workload, again, it's a small type workload. You know, we have small messages traveling backwards and forwards between the device and the cloud and the app and the external devices. But in this scenario, unlike the other ones, it's continuous data traveling backwards and forwards, which is very different to data that only occurs for, you know, a 30-second burst every now and again. Now, we did say we're looking at large-scale IT, so let's look at a connected workload, a connected car workload, right? In a connected car, I'm showing here 9 environments, or 9 IoT environments, right? We've got things like GPS, we've got things like driver assist, we've got things like environmental and entertainment, right? But each one of those IoT workloads, they have many sensors, many actuators within each one, right? And we take, for example, GPS. That can operate on the device, on the car itself. But maybe we want to talk to other cars. We want to see what's happening ahead of us. We want to know maybe there was a crash ahead of us that might delay our passage of time that maybe need us to reroute. So that information has to be fed backwards and forth. So we're connecting to other devices to make decisions. Typically, you know, 10 years ago, a car generated 0 data to the cloud service. You introduce connected cars, we're now getting 4 gig of data per day per car. And that's on the current sensors that are being developed into cars. Let's fast forward 5-10 years, there's going to be a lot more sensors, there's going to be a lot more data. There's going to be a lot more cars on the road generating that data. And therefore our cloud infrastructure needs to be able to support that. So therefore, when we are looking at our converged infrastructure considerations, you know, there's a lot of factors we have to consider. We have to consider, you know, our CPU, our memory. We have to consider, you know, read-write ops in our storage, or latency, or bandwidth. And our considerations for these devices are going to vary per device. So like I said before, is it something like the thermostat where we've got continuous data streaming to the cloud service provider and back? Or is it something like the doorbell that only activates when somebody presses the doorbell? So we can build out on that. We can build out a fog, right? Initially, we start with the IoT device. On the IoT device, we do mission-critical analysis. So, for example, in the connected car, we don't want the connected car to connect to a cloud service provider to make a decision on a potential collision that's going to happen within 10 seconds, right? So we need that happen on the car. So we do our onboard monitoring, and we have some limited storage within the car itself to provide that, right? But now, we can connect to local data center. We can connect to edge servers, and in those edge servers we can do some more analytics to what's going on in the car. We can also see what's happening in other cars in the locality of that car, and we can generate insights into that. We can also control various aspects of the car from that site. The last level is our core data center, right? And in our core data center, we're going to do a lot more, I suppose, learning and training. And in this scenario, we're going to take the data from all the different connected devices, we're going to bring it back to a high level, and we're going to train and create classifiers that we can deploy back down to the edge. And in those, once we deploy those classifiers to the edge, when the connected cars are talking to the servers on the edge, it can make decisions very quick. One thing to note here is when you're developing out of fog, you'll see that, you know, typically the device itself is very fast responding, but it's got very low computing power. However, when you move up to the core, it's very slow to respond because it's doing a lot of training work. However, it's got very powerful processor in place. Typically, we might put a GPU in place that analyzes our big data. So that wraps up my thoughts on IoT workloads for the cloud. Any questions? Thank you very much. Thank you.